This is class 33 of my arithmetic course. Today we're going to cover a few more things that I didn't cover in enough depth, or maybe things that I didn't cover at all. So we're tying up loose ends, and in the next class we're going to do some more things to tie up loose ends, and then I believe we'll have one more class before we review for the final exam, and then we'll take the final exam and the course will be over. So let's get right into it. The first thing we're going to do is we're going to, I think I covered this a little bit, we're going to study multiplying by powers of 10 and dividing by powers of 10. So this is going to be pretty easy because remember we learned that our number system is based on tens. Our entire language is, when it comes to numbers, is based on tens, most likely because we have 10 fingers, and that's what the word decimal means. It means a system of 10 when you're dealing with fractions. So what that means is that when you multiply by a power of 10 or divide by a power of 10, it makes the calculations really easy. So let's get into it just to see what we're talking about here. 6 times 10. 10 is a power of 10. Anything that has a 1 with a bunch of zeros is a power of 10. So these are all powers of 10. So that's what I mean when I say power of 10. We discussed that in a previous class. So 6 times 10, there's 1 0 on this power of 10, which means you just add 1 0 to 6, and that's your answer. So we could write the math over here and use the normal algorithm, but we just don't need to. The purpose of this, going over this, reviewing it in more detail, is to get you to understand that if you have to multiply something by a power of 10, you really should do that in your head in about 5 seconds. The purpose of this is to give you an edge when you're taking tests, placement tests, whatever, standardized tests that you might be taking, tests in school or whatever. So this is really a rule that you need to understand. Not so much because we're in a hurry, but because if the student sitting next to you knows this, then he's going to be able to he or she's going to be able to get the test done much quicker, and you're going to start to feel like you're left behind. So you need to use the fast methods whenever you can. So number 2, we're multiplying by 1,000. That power of 10 has 3 zeros. So you take 7 and you add 3 zeros. So again, I could just do that in my head. I didn't have to set up the math. So now you try number 3 and number 4, and when you come back, we'll do those two together. All right, we're back. You should have 200 because there's 2 zeros on that 100, and you should have 3 million because there's 6 zeros on that 1 million, the power of 10. So if you got 203 million, good job. All right, so now in number 5, we have a number that is bigger than the numbers we were dealing with before. We have 800. So in this case, we're just going to write the 800, and then we're multiplying by a power of 10, which has 2 zeros. So you just add 2 zeros, and we have 80,000. So same thing there. So why don't you try number 6, and when you come back, we'll do it together. All right, we're back. So you should have a 4 with 1 0 because it already has a 0, and then 1, 2, 3, 4 more zeros. So that's a total of 5 zeros. 1, 2, 3, 4, 5, and that's 400,000. So if you got 400,000, good job. So we have the same situation with number 7 and number 8. So go ahead and try number 7 and number 8, and when you come back, we'll do them together. All right, we're back. So you should have 7,000. If you got 7,000, good job. And you should have a 6 with 5 zeros. So that would be 600,000. So if you got 600,000, good job. All right, so number 9 is slightly different. Now we're not multiplying by powers of 10. So this is something different. But this calculation is still really easy because you have a bunch of zeros. Whenever you have a bunch of zeros behind numbers, and you only have to you only have two numbers, or one number each in the numbers that you're multiplying, where they're one-digit numbers, then it's really easy to multiply. So what we do here is we multiply 3 times 4 to get 12, and then we just add the number of zeros, the total number of zeros that are in both these numbers. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So we get 1,200,000. Now again, you could set it up over here, and you could use the algorithm that we learned, but it would just take a lot longer to add all these zeros, and it would just be it'll be unnecessary because you just have rows and rows of zeros. So these are cases where they are multiples of powers of 10, if you were to give this situation a name. So why don't you try, well, let's do one of these together again. So 5 times 7 is 35. Again, we have a situation where you have one number in each of these values, or one digit in each value, and then you have zeros at the end. So we can use this trick. 5 times 7 is 35, and then we just add the number of zeros. So there's 3 zeros, 1, 2, 3. So hopefully you see what's going on here. It's very easy to do this. So why don't you try number 11 and number 12, and when you come back, we'll do them together. All right, we're back. So 8 times 5 is 40. And keep in mind, this 0 is not part of the, that's not one of these zeros. That's just the 0 that came from 8 times 5, which is 40. So don't let that trick you. So now we have 1, 2, 3, 4, 5, 6 zeros. So whoops, I should probably get rid of that comma, put it in later. 1, 2, 3, 4, 5, and we'll run out of room here, so I need to shrink that. And 6 zeros. And then put our commas in. Turns out 40 million. So if you got 40 million, good job. That one was a little tricky because, again, this 0 is not part of those zeros that we counted. That came from 8 times 5, which is 40. Number 12, 9 times 2 is 18. Again, you just multiply these two numbers, and then you add however many zeros you have. So 18 and then 4 zeros. So 180,000. So if you got 180,000, good job. All right, let's try 2 more of these before we go on to a different type of problem. So why don't you try 13 and 14, and when you come back, we'll do them together. All right, we're back. 4 times 6 is 24. Now we have 1, 2, 3, 4, 5 zeros. So that's 2,400,000. Seven times 9 is 63. And 6 zeros. So if you got 63 million, good job. All right, so we're going to continue on with this principle. But now we just have a slightly different situation. Again, we're just in those problems, we're multiplying by multiples of powers of 10. This is, for example, 406,000. When you have a one-digit number and just a bunch of zeros, that's a multiple of a power of 10. This is a multiple of 1,000, and this is a multiple of 100. But now we're going back to multiplying by powers of 10 again. So the difference here is that we don't have a whole number. Well, we do have a whole number. 5 is a whole number, but we also have a fraction. So that's the difference, is we have this fraction part. And as you can see, the decimal, let me make sure that looks like a decimal there. The decimal is visible. Now in these numbers, the decimal is always to the right of the number in the ones place, which in this case are these zeros. So the decimal is there, like I explained many times before. We just don't write it when we have whole numbers. But now, because we have this fraction part, as well as the whole number, we have to write the decimal. So here's the principle. Whenever you multiply a decimal by a power of 10, in this case 100, you just move that decimal to the right, however many number of zeros are in the power of 10. So that's 2 zeros, so you move the decimal 2 places. So that becomes 568. So again, that's an extremely important trick there that you can use. It's not really a trick, but it's just a tool that you can use to do calculations quickly. So you're just moving the decimal however many number of places, the number of places that you move the decimal is the number of zeros in the power of 10. So let's do another one. Number 16. We have 1, 2, 3, 4, 5 zeros. So we're going to move this decimal 1, 2, 3, 4, 5 places. And as you can see, we're going to have to add a lot of zeros to this number because we're moving it quite a few places. So 754, and we're starting with our decimal here, right? And we'll move it 1, 2, 3, 4, 5. So you need to put zeros and get rid of that decimal because it moved all the way to here. But now that we have a whole number, we don't need to write a decimal, so it becomes 7,540,000. All right, so again, you just move the decimal however many places, or the number of times is the number of zeros in the power of 10. So why don't you do numbers 17 and 18, and when you come back, we'll do them together. All right, we're back. So we're going to move the decimal 1 place, and it becomes 3.215. So if you got that answer, good job. Here we're going to move the decimal 3 places. So we have 873 400.11 because we moved it 1, 2, 3 places. Now we put our comma, and we have 873,400.11. So if you got that answer, good job. So why don't you try number 19, and when you come back, we'll do it together. All right, we're back. So we're going to move that decimal 2 places because there are 2 zeros in the power of 10. And we get 0.1. And remember, this 0 is just written so the decimal doesn't look like a speck of dirt. All right. So when you multiply by a power of 10, you move the decimal a certain number of places. But the key thing to understand here is that these numbers did not change. It's the same numbers. That's why these calculations are so easy, is because these numbers didn't change. The only thing that changed is that the decimal moved. And, that's just because of the way that our language is designed. It's designed so that the numbering has 10 symbols. So again, that's just a coincidence. It makes calculations easy when it comes to multiplying by 10. So when you divide by 10, that's just the opposite of multiplication. So instead of moving the decimal a certain number of places to the right, we move it to the left. And the number, again, it doesn't change. So here we're dividing by 100, which has 2 zeros. So we move it 2 places. We move the decimal 2 places to the left. So we get 5.731981. All right. So as you can see, this stuff is really easy, but students tend to, when I tell students this, they tend to kind of ignore it or they kind of forget. But it's really something that you want to remember, because it's just going to make things a lot easier when you have these cases where you're multiplying or dividing by powers of 10. So let's try the next problem here. We're going to move the decimal 3 places to the left, and we're going to get 3.6784. So 1, 2, 3 places. Why did we move 3 places? Because there's 3 zeros. I think you get the point. So why don't you try numbers 22 and 23, and when you come back, we'll do them together. All right, we're back. So we're going to move the decimal 1 place. We have 87.7053. If you got that number, good job. For 23, we have 23 is kind of a different problem, because we're going to have to add placeholder zeros. We're going to move it 2 places, and then we're going to move it 2 more places. So we're going to need 2 zeros in front of that 3, because there are a total of 4 zeros. So we have our first zero, and then 1, 2, and then 3, 6, 4. So if you got 0.00364, good job. All right, so why don't you try 24 and 25? Well, actually, let's see here. I'm going to go ahead and do 24. Actually, why don't you try 24, and we'll do it together when you come back. All right, so we have to move the decimal 1, 2, 3, 4, 5 places to the left. So we're going to move it 1 place, and then we're going to have to add 4 zeros. So 1, 2, 3, 4, 1, 0, 4. So if you got that answer, good job. All right. Now, remember when we multiplied by a number? We multiplied a number by a power of 10. We added zeros. And that was the case where we had a whole number. In this case, we have a whole number, but we're dividing, so when you divide, we take away zeros. So it's just the same principle. We took away 2 zeros from this number because we had 2 zeros here. But the principle is, you have a decimal, and with these problems, the previous problems, we saw the decimal. You see these decimals here? We saw them there. In this problem, we don't see a decimal, but it's still there, and the same principle holds. We're moving the decimal 2 places over, and these ending zeros, remember ending zeros, they're not necessary. So it's all the same principle. All right, so let's try this next one. 7,000 divided by 1,000. So you move the decimal 1, 2, 3 places, or you just get rid of 3 zeros, and you just have 7. So why don't you try 27 and 28, and when you're done, we'll do those together. All right, we're back. So we have 4 zeros, and we're dividing, so we're going to get rid of 4 zeros, and that leaves us with 800. So if you got 800, good job. And number 28, we have 1, 2, 3, 4, 5, 6, 7, 8 zeros. So we're going to have to move the decimal 8 places. 1, 2, 3, 4, and then 4 more places. So we need 4 zeros in front of that 6. And we could write the other zeros, but we don't need those because remember, those are ending zeros to the right of the decimal. One, 2, 3, 4. I'm just double checking that. Looks right. All right. So that was the concept of multiplying and dividing by powers of 10. So, you can forget that if you want when you go into other courses, but it's really something that you want to remember because it just makes things so much easier because you don't have to do the complicated algorithms. So that was the first thing that we're going to learn today, tying up loose ends. And so we're done with that. Now we're going on to more rules and properties, or rules/properties. So we learned when we went into the when we learned multiplication in this class, we learned the commutative rule of multiplication, and we also briefly mentioned the commutative rule of addition. So we learned a few of these rules, but we didn't learn all of these rules. Now, to be honest with you, you don't really need these rules to go into upper math courses, but the only reason I'm teaching you these more of these rules is because you might take a standardized test, or you might take some sort of placement test where they ask you, to demonstrate these rules, or they'll require you to know what these rules are. So I don't really want to teach these rules because I know you don't really need to know the names, the fancy names for them when you go into upper math courses, but I'm just going to teach them so that you can kind of have an idea in case this comes up in some sort of placement test or whatever, or college entrance exam or high school entrance exam. Most likely it'll be a high school entrance exam, or whatever you're going to be trying to prove to somebody with exams. So also be aware, I'm calling these rules, but they're also called properties. So instead of the commutative rule of addition, it'll say commutative property of addition. So just be aware of that. All right, so let's go over this stuff. It's really most important that you remember the name of these rules. Understanding them is not super important. I mean, as long as you know the principles, you know how to use the rules. Most students in school, they know how to use the rules, but they don't even remember what they're called or necessarily why they even work. So it's not that important. The most important thing for my class is that you remember the name of the rule and what it looks like. So the first rule is the commutative rule of addition. We'll just review that. So what that means is if you have something like 2 plus 5, that's the same thing as 5 plus 2. So you can change the order of those numbers, and you'll still get 7. So both sides of the equation are the same thing. They're equal. They're both 7. That's the commutative rule of addition. And we have the same rule for multiplication, the commutative rule of multiplication. That means 7 times 5 equals 5 times 7. So commutative means you're changing the order of something. So they both equal 35. So if you're multiplying or adding, you can change the order of the numbers. So that's just a review of the commutative rule. Now we'll go to number 3 here. Now we go to the, and also number 4. These are called the associative rules. So associative means to associate, or be. It means to group things together, to come together, basically. And here's the rule. You can see they look pretty much the same, the multiplication and addition rule. So the important thing to understand about these rules is that unlike the commutative rules, you're not changing the order of the numbers. Up here, you're changing the order. You start with AB, and then it becomes BA. You change the order of the numbers. A was written first in the left side of the equation, but A was written second in the right side of the equation. So you're changing the order. With the associative rules, you're not changing the order of the numbers. You see, we have ABC, and on the right side of the equation, we have, again, ABC. You're not changing the order. You don't get ACB or BAC or something like that. Same thing with multiplication. So the associative rules are not talking about changing the order of the numbers. They're just talking about, well, it's described as changing the grouping of the numbers. So remember, we have parentheses here. Remember, PEMDAS, the Order of Operations Agreement, tells us that you do parentheses first. So what this statement is telling us is that on this side of the equation, we're adding these two numbers first, then we're adding this number. If you do that, whatever number you get, that number will be equal to the number you get when you add the second and third numbers first, then the first number. So in other words, it doesn't matter where the parentheses are. It doesn't matter which numbers you add first. And that also works for multiplication. It doesn't matter which numbers you multiply first, you're going to get the same answer. So whenever you have 3 or more numbers and you're adding all the numbers or multiplying all the numbers, it doesn't matter how you group the numbers, where you put the parentheses. It doesn't matter which numbers you add or multiply first, you're going to get the same answer. All right, so we have 4 more rules here. We have the identity rules. The identity rules are when you perform an operation on something, but you don't change it. So when you have some number, A, and you add 0, it doesn't change it. So that's called the identity property of addition. Why is it called the identity property of addition? Well, because you're adding something and it's not changing it. So I know what you're thinking. You're thinking, I don't like this stuff. Well, I know it's kind of intimidating to have to remember these fancy terms, but there's only 5, 6, 7. There's only 8 of these, and this is all we're going to be doing for these rules. I'm not going to. There are more rules, but I'm not going to make you remember them because these are typically the only ones that you're required to remember in school. So that was the identity property because A was not changed. An operation was performed. It added 0, but A was not changed. When the number is not changed, that's called an identity property. So we also have an identity property of multiplication, or identity rule of multiplication, whatever you want to call it. When we multiply a number by 1, that doesn't change it either. We learned that when we learned how to multiply numbers. So it's called the multiplication property, or the identity rule of multiplication, because we're multiplying. We're performing an operation with multiplication, and it doesn't change the number. So again, is this stuff really that important for you to remember? Not really for upper math courses, but for some situations, you do need to remember the names of these these rules. All right, so the last two, we have the 0 rule of multiplication. Whoops. The zero rule of multiplication tells us that if you multiply anything by 0, you get 0, and I don't really need to talk about that much because you already know that. Just remember that name. And then we have the inverse rule of multiplication. So this rule says that if you multiply a number by its inverse, you get 1. So when you take, well, let me explain it this way. So this number a, that number, remember, you can consider it to be a whole number, even though it doesn't have to be a whole number. You consider it to be a whole number. It would be a over 1. Remember, we can always write whole numbers as over 1. If you have, for example, 5, you can write over 1, and it's still the same value. You're kind of writing it as a fraction. Now, when you take a over 1 and you flip it so that the 1 is on top and it becomes 1 over a, this is called the inverse. So if you multiply a number by its inverse, you get 1. So that's the inverse rule of multiplication. And those are all the rules that you're going to have to remember. And again, don't be intimidated by the terms. I know that they seem really complicated, but you really only have to recognize. You have to memorize the names of the rules, and you have to recognize what they are. And as you're going to see, it's really not that hard. So let's do some practice problems here. Number 29, 3 plus 0 equals 3. So we have to name the rule demonstrated below. So we have to name this rule. What rule is this demonstrating? Well, you take 3 and you perform an operation on it and it doesn't change. So that's one of the identity properties. So it's either the identity property, or the identity rule of addition, or it's the identity rule of multiplication. So are we adding or are we multiplying? Well, obviously we're adding. So you can just abbreviate and write the identity rule of addition. And that's what we're doing here. So let's do a couple more together, and then you can do the rest on your own. Because again, these problems are really not that hard. 7 plus 1 is equal to 1 plus 7. So you're changing the order of the numbers. So that's probably going to be a commutative rule. We just need to figure out if it's addition or multiplication. Well, obviously you can see it's addition. So it's again, you can abbreviate the commutative rule. That was kind of a weird looking R. Commutative rule of addition. And so why don't you go ahead and try the rest of these problems. They're really not that hard. Again, you can abbreviate your answers. And you have the rules written here. So you can refer to those as you do these problems. And go ahead and do problems. Well, I don't want you to get too ahead of me, so why don't you do the first 2 problems, and when you come back, we'll do them together. Numbers 31 and 32. All right, we're back. So you have 4 times 1 equals 4. You're multiplying by something, and it's not changing the number. So that's the identity property, or identity rule of multiplication. So if you got that answer, good job. Number 32, you're changing the grouping, or you're changing which numbers you multiply first, and so that's going to be the associative rule of multiplication. All right. So if you got those answers, good job. So why don't you try numbers 33 and 34, and when you come back, we'll do them together. All right, we're back. 33 is the commutative rule of addition, because you're changing the order of the numbers and you're adding. 34 is the zero rule of multiplication, because you're multiplying by 0 to get 0. And don't be fooled because I changed the order. Notice I flipped some of these equations. So I took a and multiplied by 0 to get 0 in the rule, but then I flipped it the other way around down here, so it's still the same rule. So don't be fooled by that. All right, let's do numbers 35 and 36, and when you come back, we'll do them together. So go ahead and attempt 35 and 36 on your own. All right, we're back. So you're multiplying 4 by its inverse to get 1. So that must be the inverse rule of multiplication. So if you got that answer, good job. Number 36, this is telling you it doesn't matter which numbers you add first. You get the same answer, so that's an associative rule of addition. So if you got that answer, good job. So again, you should be using your rules up here. Try numbers 37 and 38, and when you come back, we'll do them together. All right, we're back. So you're changing the order of those numbers, and you're multiplying. So it's because you're changing the order, it's got to be the commutative rule. And because you're multiplying, obviously it's the commutative rule of multiplication, not the commutative rule of addition. All right, 38. You got to remember to keep those on the page so we can see those. 38, we're multiplying a number, the number being 9. We're multiplying 9 by 1, and we don't change the number. We still get 9. So that is the identity property, or identity rule of multiplication. Why multiplication? Because you're multiplying. All right, so try number 38, 39, and 40, and when you come back, we'll do them together. All right, we're back. We're changing the order of the numbers, so it's commutative rule, and it's addition, so we put an A for addition. Again, we're just identifying the rules here. And number 40, it's multiplication, and we're just changing which numbers we multiply first, so that's going to be the associative rule of multiplication. So if you got associative rule of multiplication, good job. So that's it for those rules. So we learned how to multiply and divide by powers of 10 on page 1, and we learned the different rules, also called properties, on page 2. So now we just have one more thing to do today. At least I have one more thing to do. You have to do the homework. We're going to learn how to write quotients as mixed numbers. This is something that I didn't really go over much, and so I'm covering it now. So it says here, divide the numbers below, write the quotients as mixed numbers. So let me explain what's going on here. So we learned division, obviously quite a while ago. And we learned if you have a remainder, we write it like so. So 7 divided by 4, 4 goes into 7 one time, and then we would write remainder 3, because 7 minus 4 is 3. There's 3 left over after 4 goes in one time. So that's how we learned how to write it when we have whole numbers. Now, if you wanted to write it as a decimal, obviously you would just use the long division algorithm. 7 divided by 4 goes in one time, remainder 3, but then you'd put a decimal and a 0 and you'd keep going. 7 times, 28, 2, 4 goes in 5 times, 20, and you'd end up with 1.75. But what if you don't want to write the answer with an R in a remainder? And what if you don't want to write the answer as a decimal? Well, there's a way to quickly write the answer as a mixed number. Now, we could just change 1.75. We could change that to a mixed number. We know that's 75 over 100, because the 5 is in the hundredths place. The number farthest to the right, on the right side of the decimal, that tells us what the denominator is going to be. It's because it's in the hundredths place. And then we could reduce that to 1 3/4 by dividing both sides of this fraction by 25. So that's one way to change it to a mixed number, but there's a much faster way to change it to a mixed number, and that's what we're going to learn right now. So here's how we do it. 4 goes into 7 one time. There's 3 left over, and whatever the divisor is, remember this is the dividend, 7 is the dividend, 4 is the divisor. We put the divisor in the denominator, and there you go, that's it. So that's a very fast way to find the quotient. We used remainders in the beginning parts of this class. We just wrote R3, but it's much better to go ahead and write the quotient in this form, because then we can actually use it in calculations. So 9 divided by 2, 2 goes in 4 times, and there's 1 left over because 2 times 4 is 8, 9 minus 8 is 1, 1 left over, and the divisor goes in the denominator. So again, this stuff is very easy. So this stuff definitely makes sense, because if you take 7 and you divide it into 4 parts, each part would be 1 3/4. That's the size of each part. Now, why does that work out that way? Well, it just does. There's no real way to explain why that works. You just most students don't really even think about it. So 43, let's do 43 together. You can try the next 2 on your own. 8 divided by 5, 5 goes in 1 time. There's a remainder of 3. And 5 goes in the denominator because it's the divisor, and there you go, 1 3/5. So if you divide 8 into 5 parts, the size of each part would be 1 3/5. Again, this is just something that I only went over a little bit in the rates and ratios course, ratios and rates course. So we're going over with a little bit more detail here. So why don't you try 44, and pause the video, and when you come back, we'll do it together. All right, we're back. 7 divided by 3. 3 goes into 7 2 times. 3 times 2 is 6. 7 minus 6 is 1. And then the divisor goes in the denominator. So you could say 3 goes into 7 2 1/3 times, but really a better way to interpret that is if you divide 7 into 3 parts, each part would be 2 1/3. And that would be the size of each part. All right, so if you got 2 1/3, good job. Try number 45, and when you come back, we'll do it together. All right, we're back. 5 goes into 12 2 times. 5 times 2 is 10. So 12 minus 10 is 2. And the divisor, which is 5, goes in the denominator. Again, this is the divisor, so it goes in the denominator. That's the way it works every time. So if you got 2 2/5, good job. All right, so now we have 78 divided by 9. 9 times 8 is 72. 9 times 9 is 81. So 9 times 8 is 72, so it's 8. 78 minus 72 is 6, and you get 8 6/9. But don't go anywhere, because we can reduce that. Divide both sides of this fraction by 3, and we get 2 over 3. So that would be 8 2/3. So those were some bigger numbers we had to deal with. We had to use our multiplication facts. All right, number 47. How many times does 8 go into 59? Use your multiplication facts. Let's see, 8 times 5 is 40. 8 times 7 is 56. Looks like it's going to be 7. 59 minus 56 is 3, and the divisor goes in the denominator. So again, we're taking these quotient expressions, and we're writing the quotient as mixed numbers instead of decimals, which we've done quite a few times in this class. All right, so 48. attempt 48, and when you're done, we'll do it together. Pause the video. All right, we're back. 9 times 8 is 72, so it looks like it's going to be 8 times, and 76 minus 72 is 4, and the divisor goes in the denominator, so 8 and 4/9. 6, and yeah, so if you got 8 and 4/9, good job. Try 49, and when you come back, we'll do it together. All right, we're back. 6 times 8 is 48. 52 minus 48 is 4. Divisor goes in the denominator. But don't go anywhere because we can reduce 4 over 6. Divide both 4 and 6 by 2 and you get 2 over 3. So 8 and 2/3. It's kind of coincidence that these two ended up being the same. All right. 48, 52. Just double checking my answer there. Looks right. So again, we just learned how to take a division expression or quotient expression and change it into a mixed number. So this is useful when we're figuring out unit rates. So down here we have a bunch of rates, but we're going to change these rates into unit rates. Now we covered this a tiny bit in the rates course, or the rates class, the class on rates, but we're just going to cover it in a little bit more detail here. So we have 51 miles in 9 minutes. That's a rate. These are all rates. Why are they rates? Because the units are different. You have, in this number you have miles, and in this number you have minutes. Those are different units. Minutes and miles are not the same units. So that's called a rate because there are more than one unit. Gallons and yards, that's a rate because there's more than one unit. So you're taking two numbers and you're giving a relation between those two numbers like you do with ratios, but the difference is that with rates you have different units. But of course, like I mentioned previously, when you're using ratios, that rule is violated, and ratios are often written with more than one unit or different units also, so be aware of that. Also, all right, so 51, in order to change a rate to its unit rate form, you may recall all you do is take the first number and divide by the second number if you want miles per minute. Now, if you want minutes per mile, then you would divide it in the other direction. You divide 9 by 51, but we're not going to get into that today. Always divide the first number by the second number. So in other words, there's two forms of the unit rates. All right, 51 divided by 9. So 9 goes in, let's see, 9 times 5 is 45. Let me go ahead and write that. So 9 times 5 is 45. That's going to be the whole number. And 51 minus 45 is 6. So we have 5 and 6/9. The 9 goes in the denominator because it's the divisor. And that reduces to 5 and 2/3. Oh, and I have to write my units. That's the most important thing. Miles per minute. So we're just finding unit rates, but we're writing the unit rates with mixed numbers. Again, we touched on this a little bit in the ratios and rates class, but we're going into more detail now. All right, number 51. Why don't you try number 51, and when you come back, we'll do it together. All right, we're back. To find the unit rate, again, this is just a random rate. This is not the unit rate. In order to find the unit rate, we need this number to be 1. We need this number to be 1. When I wrote 5 and 2/3 miles per minute, that means 5 and 2/3 mile for every 1 minute. I don't write a 1 there, but it's assumed to be for every 1 minute. So that's what we're looking for here. We don't want the number of gallons in 6 yards. We don't want that. We want the number of gallons in 1 yard, or for 1 yard. That's called a unit rate. So we divide 26 by 6, and 6 goes in. Let's see, 6 times 4 is 24. 26 minus 24 is 2. So we have 4, and divide both. And we have 4 and 1/3. Divide both numbers by 2, we get 1/3, and we have gallons per yard. So again, gallons per yard means for every 1 yard. So 4 1/3 gallons for every 1 yard. Again, I don't write the 1 because it's just traditional not to write the 1. But that's what that is. That's the unit rate. So both these rates are equivalent. Both these rates are equivalent. They're equivalent rates. They're the same value. They're just different forms. These are just random rates, but these are the unit rate form. And why are we doing this? Why are we going over this part of the course again? Well, just to learn how to change these rates so that they're in mixed number form. All right, now I just want you to be aware that if you have a decimal, this type of thing really doesn't apply. For example, if you try to change this to a unit rate, say you had 144.2 gallons of gasoline, and you could drive 5 miles on that gasoline. Maybe it's rocket fuel or something. You want to figure out how many gallons the rocket can move in one, or how many gallons it'll take to move 1 mile. That's the unit rate. So you take 144.2 and you divide by 5. But in this case, you're going to see that it doesn't really work. Let me show you what I mean. So 5, this is actually a pretty big number. Let's see here. So we're going to have to use the long division algorithm. I just realized we haven't used the long division algorithm yet, but before we do that problem, let's go down here and do this one. So again, we have the same situation. We just divide the first number by the second number. But this number is quite big. 117 is quite big, so we're going to have to use the long division algorithm. So I just want to jog your memory here. So we'll do that over here. 117 divided by 7. 7 goes into 1 no times, but it does go into 11 one time. Notice I put the 1 above the last digit of the number I'm dividing into. 7 times 1 is 7. Subtract. Bring down a 7. 7 goes into 47 6 times. 7 times 6 is 42, and we have a remainder of 5. So your remainder is 5. This is the same exact problem that we were doing before. The whole number, it goes in 16 times. 7 goes in 16 times, but there's a remainder of 5. Now again, you could put a decimal here and drop down a 0 and keep going if you wanted to change it to a decimal, but we don't want to change it to a decimal in these problems. We could. There's nothing wrong with that, but in these problems we would prefer to write the answer as a mixed number, and that's especially true in this case because you have a 7, which means you're going to have a repeating decimal, and the repeating decimal is going to have a pattern of 6 numbers, which is very difficult. This is going to go, all the way down to here. So it's 16. The remainder is 5. So when you have to use the long division algorithm, your remainder is going to be down here. When you don't have any more numbers to go, there's no more numbers up here, so our remainder is going to be down here. After there's no more numbers left, that's the remainder. So the remainder goes in the numerator, and the denominator, as usual, is the divisor. And that's servings per pound of dough. So that's the unit rate. So let's do another one of those before we get to the special case that I was doing up here. So 8 into 37. I guess we don't really need the long division algorithm for that. Let's do another one that requires long division algorithm before I go back to that other problem. So again, we just divide this number by this number to find the unit rate. The first number by the second number. So 830 divided by 3. So we'll do that over here. That's quite a big number, so we have to use the long division algorithm. 3 goes into 8 2 times. And then 3 goes in 7 times is 21. And 3 goes into 20. 6 times is 18. And now we don't have any more numbers here. So the number that we bring down, or the number that comes up when we subtract is going to be the remainder. So we have 2. So what that means is that 3 goes into 830 276 times. That's that number there. The remainder is 2, and so that goes in the numerator. And then the divisor, 3, goes in the denominator. So as you can see, it's just the same exact situation. Whoops, we have to put our units, ounces per gram. Gram is abbreviated as G. Ounce is abbreviated as OZ. So that means 276 2/3 ounces for 1 gram. That's just the notation that means for 1 gram. All right, so that's just a way to write the quotient with a mixed number. And so, again, we're doing the same thing we did up here. The only difference is the division is much more complicated because we had bigger numbers like 117 and 830. So we had to use the long division algorithm. And the remainder ended up being down here, you see. After there were no more numbers, the remainder is here. So same situation here. After there were no more numbers, the remainder was here. Again, in the other problems, we would just write R2, remainder 2. But in these problems, we don't want to write R2. We want to write a number that we can use in calculations. So we write 2, and then the divisor in the denominator, and we have a mixed number. So now let's go to this problem. When you have a decimal, this situation really doesn't work, this direction. So you don't have to worry about writing this quotient as a mixed number. We would never do that. We just write it as a decimal. And let me show you why. If you take 144.2 and you divide by 5, 5 goes into 14 2 times, subtract, bring down the 4. 5 goes into that 8 times, 40, bring down a 2. And 5 goes in 8 times again. 5 times 8 is 40, so we put the 40. Put the 40 down there. And as you can see, there are no more numbers here. So our remainder down here, 2, or the number down there, 2 is the remainder. So we've got a remainder down here, which is 2. Sorry, I'm writing kind of small there. And so we bring the decimal straight up, and we have 28.8, but it's not right to say remainder 2, and it's not right to put a mixed number because there's a decimal here, which means it's a much different situation. So the 2, when we write 2/5, that would actually be 2/5 of 1/10. Because the 8 is in the 10th place, so it gets much more complicated. So long story short, it's not 2/5 of 1 whole; it's 2/5 of 1/10. So you don't need to write mixed numbers. I guess I can just leave that there. You don't need to write mixed numbers when you have decimals. It's just not traditional to do that. So if you didn't understand any of that, that's okay. I'm just trying to explain very quickly why you don't use mixed numbers when you are dividing by a decimal traditionally. All right, so let's get a few more of these problems done. Actually, I think it's your turn, so why don't you do number 53. Again, you're going to write the answer as a mixed number. So when you come back, and you won't need to use the long division algorithm for this because your multiplication facts will be enough. So divide 84 by 9 and write the answer as a mixed number. When you come back, we'll do it together. Pause the video. All right, we're back. So 84 divided by 9. 9 goes in 9 times, because 9 times 9 is 81. 84 minus 81 is 3. Divisor goes there. And keep going, because we can reduce 3 over 9 to 1 over 3. And that is dollars. Dollar sign is usually written to the left of the number, so I'm going to move that over. 9 1/3 dollars per minute. Maybe that's how much it costs to call long distance or something. Now, of course, there's no such thing as 1/3 of a dollar in terms of our money system, but you get the point. So if you got 9 1/3 dollars per minute, good job. Try number 54, and when you come back, we'll do it together. All right, we're back. Divide the two numbers. Again, we're finding the unit rate. 8 goes into 37. Let's see, 8 times 4 is 32. 37 minus 32 is 5. So we get 4 5/8 hours per machine. We don't really have an abbreviation for machine, so we can just spell out machine. But H is the abbreviation for hours. It's used in math and science. All right. It's probably best just to spell out hours, though. So if you got 4 5/8 hours per machine, good job. That means 4 5/8 hours for one machine. That's how many hours it takes to build one machine, or do whatever you're going to do that with the machine. All right, so we have 5 more problems here. So this is going to be a shorter than normal course or class. So we just have to get these 5 problems done, and then the video will be done and you can do your homework. So why don't you try number 20 or 57. Pause the video, and when you come back, we'll do it together. All right, we're back. 2,133 divided by 6. Again, we're looking for the unit rate. So we're going to use our algorithm, long division algorithm, because these are big numbers. And we have no more numbers here, so we're going to stop there. We have a remainder. So it goes in 355 times. Our remainder goes here, and our divisor, 6, goes here. So we can go down here because we have to reduce the 3 6. That becomes 1/2. And let me move this stuff over. Let's see here. It's 355 1/2 cups per teaspoon. I think the abbreviation for teaspoon is TSP, if I remember correctly. I may be wrong about that. All right, so if you got 355 1/2 cups per teaspoon for every 1 teaspoon, good job. Try 58. Actually, 58 is going to be slightly different, so we should do that one together. Now, this is a situation where it's going to be really, really easy. Because in this situation, the first number is smaller than the second number. So that's kind of weird, because obviously 8 is not going to go into 7 at all. But technically 8 does go into 7. Let me rephrase that. A fraction of 8 goes into 7. Part of 8 goes into 7. 7 out of the 8 goes into 7. So 7/8 of 7, or 7/8 of 8 goes into 7. Now that's where division starts to get a little bit weird. So all you need to know is if you're dividing 7 wholes into 8 parts, each part is going to be 7/8 of a whole. Now again, why does that work? Well, it just works. Take 7 apples and try to divide them into 8 parts, and you'll find that each part is going to be 7/8 of an apple, of a whole apple. So whenever you take a number and divide by another number, you can just write it in fraction form. And even if the first number were bigger, even if you had 8 divided by 7, the first number is bigger in this case, the dividend, you could still write it as 8 over 7. And then you could change it. This is now an improper fraction. 7 goes in one time, and the remainder is 1, and the divisor, so remember we went over that in previous classes. So the principle of writing division as a fraction works in every case pretty much. But this is a special case because 7 divided by 8 is just 7 over 8. It's so easy. Not easy to understand as far as the actual math, but easy to perform the math itself. So cubic feet, that's ft to the third power. That's the abbreviation for cubic feet. So you just take the first number and write it over the second number, and that's it. Now you can change this into decimal form. You can write it in different ways, but it's easier just to write it as 7/8 kilograms for every 1 cubic foot, or per cubic foot. So why don't you try 59, and when you come back, we'll do it together. All right, we're back. 4 divided by 9. You can just write that as 4/9 pounds per dog. 4/9 pounds of meal per dog. That's the fraction of a pound of meal that every dog is going to get. So again, these are pretty easy. Now again, you're probably thinking, well, wait a second, we're dividing by, what if we divided 8 by 7? Couldn't we just write it as 8/7? Well, yeah, you could write it as 8/7, but the only problem is it's an improper fraction. So we don't want to write improper fractions, so it would be better just to say, how many times does 7 go into 8? It goes in one time, the remainder is 1, and divisor 7. Now you can, like I said, you can also write it as an improper fraction and then just convert the improper fraction to a mixed number. I know we haven't done that in a while, but we did go over that. That's another way to do it. But all these methods are just ways to write the quotient. And the reason it works is it always works that way when you divide whole numbers by other whole numbers. So why don't you try 60, and when you come back, we'll do it together. All right, we're back. 11 divided by 15. That would just be 11 over 15 miles per gallon. So if you got 11 over 15 miles per gallon, or left 11/15 miles per gallon, good job. 11/15 of a mile per gallon is the proper way to say it. 61, 8 divided by, well, why don't you go ahead and try that one, and when you come back, we'll do it together. All right, we're back. 8 divided by 13 is 8 over 13, or 8/13 of a piece of chocolate. Or we can just say piece per person. Again, it's the unit rate, so it's not going to be people. It's going to be for every one person. So 8/13 of a piece of chocolate per person. So I know this stuff is very strange, but you're going to have to get used to this. You're going to understand more about this when you take the next course, pre-algebra. And you're going to do this a zillion more times in upper courses. So right now you don't really have to worry about this that much. You just have to know enough to get the homework done, and then we'll review this in more detail before we take the final exam. So we learned 3 things. We reviewed multiplication and division of powers of 10, which we went over briefly, but we didn't go over much, so I wanted to go over it in more depth. We went over most of the rules of math, also called properties. So we learned how to name those and how to recognize them. And we went over this strange case of when you're dividing 2 whole numbers, you write the quotient as a mixed number. And we applied that to converting rates to the unit rate form. So here's the homework for today. You can get a screenshot of that, or you can get a screenshot of the first 2 pages and a screenshot of the second 2 pages. So as you can see, the answers are there as usual. Do the homework completely and correctly. Check all your answers. Make sure that you get the right answers, so on and so forth. Take the course seriously. If you don't do the homework, you'll learn nothing in this class. I guarantee, just like every text at the end of the video that I give you, every sign at the end of the video. So that's class 33. And in the next class, we're going to go over a few more things. We're going to do a few more things, part 2. And then I believe, again, we're going to have one more class, and then we'll be done with the material in the course. And then we'll just review for the final exam and take the final exam, and you'll be done. And once you're done with this class, you'll be done with K through 5 mathematics. Kindergarten, 1st grade, 2nd grade, 3rd grade, 4th grade, and 5th grade. And you'll have a lot of stuff done from 6th and 7th grades. So I'm proud of you if you've made it this far, and if you've done all the homework and studied for the exams and passed the exams. And I'll look forward to seeing you in class 34.